Hi students, in this lecture we are going to learn the conjugate of a complex number and the properties of conjugate of a complex number. Before that, in the previous lecture we learned how to find out the square root of a complex number. So the square root of a complex number generalized as for any square root of a plus ib, we obtained a plus or minus square root of a square plus b square plus a by 2 plus iota times of square root of a square plus b square minus a by 2. Okay, if the b is positive, where is an imaginary part of the complex number, then we uses this formula. That means the resultant is nothing but in the form of plus or minus x plus iy. Okay, where x is equals to, this is the term, and y is this one. Okay, so if it is b greater than 0, if it is b less than 0, then the complex number will become square root of a minus ib. A minus ib, then we will get, it is in the general form as what it is, plus or minus x minus iy is the resultant. Plus or minus x minus iy is the resultant. Okay, now I am considering one example. So find the square root of the complex number. Okay, find the square root of the complex number minus 5 plus 12i minus 5 plus 12i square root. Okay, square root of the complex number asking us to find, this is the square root. Okay, we know that by using the above formulas. Okay, which is the suitable formula? Here b equals to 12. Okay, here b equals to 12. So from this one, here b equals to 12, which is equals to greater than 0, that means which is equals to positive. Then we have to use the first formula. Okay, then what we'll get is 5 minus 5 plus 12 times of I square root, as here a equals to minus 5. Okay, a is equals to minus 5 and b is positive, then we'll get, it is in the form of plus or minus x plus iy. Okay, so now use the formula plus or minus, then what we are getting over here, a equals to minus 5 square root of, okay, square root of, and again square root of a square minus 5 whole square. Okay, a square plus b square, that means 12 whole square. Okay, then plus a, what is plus a is nothing but minus 5 by 2, and we are getting over here plus I into, okay, iota into, then again we are getting it as square root of, okay, again square root of minus 5 whole square plus 12 square, and now here minus of a, that means minus of minus 5 by 2. Okay, minus of minus 5 by 2. Why? It is b greater than 0, we are using the first formula. Then if we simplify this, what we'll get over here, and square root of, and what it is, 25 plus 144, 169, square root of 169, directly I'm writing here, it is as 13. Okay, minus 5 by 2, this resultant we will get it as a 13 plus iota times of square root of 13 plus 5 minus 5 plus 5 by 2. Okay, 13 plus 5 by 2. Okay, so resultant, what we'll get over here, the resultant we'll get over here, it is as, so plus or minus, we'll get here, it is as a plus or minus 13 minus 5 8 8 by 13 minus 5 8 by 2, square root of 4 means we will get over here, it is as a 2 plus iota times of 18 by 2, then we will get here, it is as a 3, then the resultant equals to plus or minus 2 plus 3i, which is the square root of the given complex number minus 5 plus 2i. Okay, so now you can find the square root of what is I. Okay, square root of I. Okay, then find what is square root of I. Here it is nothing but, in the complex form we can write it as real part is 0, iota times into 1. Okay, iota times into 1. So that means which is equals to, so from this one I can write it as a equals to 0 and b equals to 1. Okay, then the square root of I. Okay, square root of I. Here the b is greater than 0, and which formula we need to use it as, then square root of I, which is equals to square root of 0 plus I into 1. As b greater than 0, then we have to use plus or minus what it is, square root of a square plus b square plus a by 2 plus iota times of square root of plus a square plus b square minus a by 2. Okay, by using this formula we can find out the square root of a complex number, what is iota. So here which is equals to plus or minus a equals to 0 and b equals to 1. Just simply square root of, and square root of a equals to 0 square plus 1 square plus 0 by 2 plus iota times of square root of, so square root of 0 square plus 1 square minus a 0 by 2. Okay, then what will get the resultant, plus or minus, okay, so which is nothing but 1 by 2 plus, simply it is nothing but I into again 1 by 2. Okay, so we can write this as plus or minus 1 plus I by 2 is the square root of the complex number iota. Okay, square root of the complex number iota is plus or minus 1 plus I by 2. And similarly, what is the square root of minus 1? Okay, then what is the square root of minus, sorry, iota? Square root of minus iota, which can be written as 0 plus iota times of minus 1. Okay, the real part is 0 plus iota times of minus 1. So from this one we can write it as a is equals to 0 and b equals to minus 1, which is nothing but less than 0. If b is less than 0, then what we have to use the formula, plus or minus square root of a square plus b square plus a by 2 minus iota into square root of a square plus b square minus a by 2. Okay, then we will get the square root of minus iota equals to, substitute a equals to 0 and b equals to 1. Then we will get over here square root of 0 square plus 1 square plus 0 by 2 minus iota times of square root of 0 square plus 1 square means 1 minus 0 by 2. Okay, which is equals to plus or minus 1 minus iota by 2. 1 minus I by 2 is the square root of minus 1. Okay, then you can try to find out the square root of a plus ib. Okay, try to find out the square root of a plus ib. We have the formula. Okay, the first formula, plus square root of a minus ib. Okay, square root of a minus ib. Okay, so then find out this one, you will get the required result. So this is the way of finding the square root of a complex number. Okay, now we will discuss what is a conjugate. What is a conjugate? Simply that conjugate, let we are considering a complex number z which is equals to a plus iota times of b. Then the conjugate of z, we already discussed this in the multiplicative inverse. While discussing the multiplicative inverse, we already discussed about the conjugate of a complex number. The conjugate of complex number z is denoted by, how it is denoted, z bar, z conjugate. Okay, z bar, z conjugate is obtained by simply changing the sign of the imaginary part. B is positive here, simply make it as a negative. Changing the sign of the imaginary part, we obtain the conjugate of a complex number. Okay, we'll obtain the conjugate of a complex number. Clearly that z equals to a plus ib and its conjugate z bar can be written as a minus ib. Okay, so in a complex number where the real part of z is nothing but here in this one a, and the imaginary part of the complex number z is b. Okay, real and imaginary parts. Okay, now how to express the real part as in terms of complex number and its conjugate. So now if we add these two, then what we'll get over here, z plus z conjugate equals to what we'll get, simply it is as 2a. That implies a equals to, which is nothing but z plus z conjugate by 2, where a is nothing but the real part of the complex number. Always the real part of the complex number is nothing but the average of the complex number and its conjugate, is nothing but the average of the complex number and its conjugate. Now how to find out the imaginary part? Okay, now how to find out the imaginary part? Simply subtract. Okay, now z is equals to a plus ib and z conjugate equals to a minus ib. Just subtract these two, then what will get, minus minus, over here it is plus, then we can write it as z minus z conjugate equals to 2 times of ib. Okay, so from this one b can be written as z minus z conjugate by 2i. Okay, so what is this b? B is nothing but the imaginary part of the complex number in terms of the complex number and its conjugate as z minus z bar by 2. Okay, z minus z bar by 2. So now we had discussed about the complex conjugate of a complex number as z is equals to a plus ib and its conjugate written as a minus ib, simply changing the sign. And the next property about the real part of a complex number can be written as z plus z conjugate by 2, and the imaginary part of a complex number can be written as z minus z conjugate by 2. Okay, so now the third one. Okay, now the third one, if z is a real number, if z is a real number, okay, when a complex number is said to be real. Okay, if it is real, what happens? The real means I am considering z is equals to a plus the imaginary part is 0, imaginary part is 0. Then what's its conjugate? The conjugate of z, now what it will become, the conjugate of z? So we can write as z conjugate is obtained by simply changing the sign of the imaginary part. That means if it is minus 0, so whatever it is, nothing changes. So which is equals to a. Okay, so simply that if z equals to z conjugate, that means if z is equals to z conjugate, then the complex number, z is a real number, is a real number. Okay, then the complex number z is a real number. Now I'm considering other property. What is this property? If z is equals to the complex number, z is equals to a imaginary, okay, that means I'm considering some iota times of b. Here the real part is 0. If the complex number is imaginary, then what is the condition we will get? Okay, if the complex number is imaginary, then its conjugate can be written as z conjugate. Z conjugate equals to, change the sign of the imaginary, then it is minus ib. So that means if a complex number is imaginary, so then we obtain the condition as z equals to minus z. Okay, z equals to minus z. From this one we can say that if z is equals to minus, okay, if z is equals to minus z, okay, otherwise z conjugate, sorry, here it is z conjugate. If z is equals to minus z conjugate or z conjugate equals to minus z, okay, or z conjugate equals to minus z, then okay, z conjugate equals to minus z, then we can say that the complex number z is an imaginary number. Z is an imaginary number. Okay, complex number z is imaginary number. Okay. Okay, moving for the next properties. If I am considering z1 equals to a plus ib and z2 equals to c plus id. Now z1 conjugate equals to, we obtain it as a minus ib. Z2 conjugate, we obtain this as c minus id. Then now I am writing it as z1 plus z2. Okay, what will get z1 plus z2 equals to a plus c plus iota times of b plus d, which is z1 plus z2. So now what is the conjugate of z1 plus z2? Conjugate of z1 plus z2 equals to a plus c minus iota times of b plus d. It is obtained by simply changing the sign of the imaginary part. If we expand this, what we'll get? A minus ib is the one term, plus we'll get c minus id is the another term. That means a minus ib is nothing but z1 conjugate, plus c minus id is nothing but z2 conjugate. So we can write it as z1 plus z2 whole conjugate equals to z1 conjugate plus z2 conjugate. Okay, so this is another important property for the conjugate of a complex number. Okay, conjugate of a complex number. Okay, so z1 plus z2 whole conjugate equals to z1 conjugate plus z2 conjugate. Okay, similarly, now multiplication, z1 equals to, we are considering a plus ib and z2 equals to c plus id, and the z1 conjugate we obtain it is as a minus ib, and z2 conjugate we obtain this is as c minus id. Then what is z1 into z2? What we obtain the z1 into z2? A plus ib into c minus id. Okay, z1 into z2. So what we obtain z1 into z2 as, simply it is as ac minus bd. Okay, z1 into z2 as ac minus bd. Okay, I'm writing over here ac minus bd. Okay, plus iota times of ad plus bc or bc plus ad. Okay, so which is the required result? Then what is z1 into z2 conjugate? Z1 into z2 conjugate we obtained as ac minus bd. Okay, now simply change the sign of the imaginary part, which is equals to bc plus ad. Okay, so now what is z1 conjugate? Sorry, here we forget to write as conjugate. Okay, so now what is z1 conjugate into z2 conjugate? What we'll get over here? A minus ib into c minus id. Then if we perform the operation a into c, ac minus I times of ad minus I times of bc, and which is equal minus I square. Okay, minus into minus plus I square times of bd. Okay, then we can write this is as what it is, ac which is equals to minus 1 ac minus bd as the real parts, and if I take minus as a common, then what we'll get? bc plus ad. Okay, so the z1 into z2, z1 conjugate into z2 conjugate we are getting. Now these two are equal, so that means which is nothing but z1 conjugate into z2 conjugate. So from this one we can write it as z1 into z2 whole conjugate equals to z1 conjugate into z2 conjugate. The product of the two complex numbers conjugate is equals to the product of the individual complex numbers conjugate. Okay, I am repeating it again. The product of the two complex numbers conjugate is equals to product of two individual complex numbers conjugate. Okay, so z1 into z2 equals to whole conjugate equals to z1 conjugate into z2 conjugate. And another important property, I am considering z is equals to a plus ib. Then what is the conjugate of this one? We obtain simply changing the sign of the imaginary part. If again I conjugate this z conjugate, then again we need to change the sign of the imaginary part. Here we are having minus, then it will become plus, which is equals to z conjugate whole conjugate equals to z. Another property is z conjugate whole conjugate equals to the complex number itself. Okay, z conjugate whole conjugate equals to the complex number itself. Okay, now the another property. Okay, what is the another property over here? Z1 by z2, z1 by z2 whole conjugate. Okay, z1 by z2 whole conjugate equals to z1 conjugate by z2 conjugate. Okay, z1 conjugate by z2 conjugate. Okay, so for this one, just consider I am giving this is a proof for this proof as an assignment. Then you can consider as z1 equals to a plus ib and z2 equals to c plus id. Okay, then perform the division z1 by z2. Okay, then you will get the required operation as already we performed in the division of a complex number. Then find out the z1 by z2 whole conjugate. Okay, you will get the result over here. Then next, find out the z1 conjugate, you know, from the z1 and the z2 conjugate, and again you find out the division between these two, you will get the another equation 2. Now these two are equations must be same, then you will get the proof of this lost property. Okay, so these are the properties of a conjugate of a complex number. Then in the next lesson, next section, or we will discuss some another topic.